Jersey here. In this question we're told we have a point P and we have a circle with centre C, and we're told to find an expression for the distance between C and P. So let's first of all see what we can find out about this circle. X minus 1 squared plus y plus 2 squared equals 25. And remember the result that if we have a centre AB and radius R, then the equation of that circle is that x minus a all squared plus y minus b all squared equals r squared. So in this case, we know that the centre C is 1, negative 2. You compare that with AB, x minus a, y minus b. We would have to be minusing negative 2 to get a plus 2 there. So 1, negative 2 is the centre, and the radius is square root of 25. That's the radius squared, 25, so it's 5. So we know that C is the point 1, negative 2, and we know that P has coordinates 4, K. So the distance between these two, this is the distance formula, would be the x difference squared plus the y difference squared. So let's do it with this point first. 4 minus 1 squared plus k minus negative 2, that's k plus 2 squared. So that's the result, the distance formula, x1, y1, point x2, y2, we call these a and b. The distance between these 2 points is square root of x2 minus x1 squared plus y2 minus y1 squared. That's the result I was using, distance formula. So it's the square root of 4 minus 1 all squared plus k minus negative 2 all squared. Let's try and figure out this in a simplified form. 4 minus 1 is 3, 3 squared is 9. Let's work out k plus 2 times k plus 2. The first two terms give us k squared, and the outside 2, 2k, inside 2, 2k, so that's 4k, and the last give us 2 times 2 is 4. So we get square root of, there's a k squared plus the 4k, and 9 plus 4 gives us 13 as required. So that was part A. We've shown that the distance from C to P is that. Let's have a look at part B. Hence, or otherwise, find the range of values of k such that P lies outside the circle. Now, for P to lie outside the circle, well, let's have a look at a picture. There's circle, P outside it, there's centre C. Notice the radius, remember, of the circle was 5. So the only condition that we'd need to impose for P to be outside that is that the distance from C to P must be greater than the radius 5. Otherwise it would be on or inside the circle. So for P to lie outside the circle, we require that distance C to P to be greater than 5. Well, we know the distance from C to P. We've worked that out. It's k squared plus 4k plus 13. So that distance greater than 5. Well, let's keep going with this. Let's square both sides. Now, they're both positive numbers. If we've got a being greater than b, then a squared will be greater than b squared, providing they're both positive numbers, which these are. It gets a bit more complicated if one of them's negative, but they're both positive, so we can square both sides and keep that inequality intact. So if we square the square root of this, the square root just disappears. 4k, k squared plus 4k plus 13, that'll be greater than 25. And let's take 25 away from both sides, k squared plus 4k, and 13 minus 25 would be minus 12, and that's greater than 0. So we can see that we've ended up with a quadratic inequality. We want to know when are the values of k squared plus 4k minus 12 greater than 0. Well, let's suppose, first of all, let's suppose that k squared plus 4k minus 12 equals 0. Because, you know, if we were to draw a graph showing the values of k squared plus 4k minus 12, that's not the x-axis, the k-axis, if we show the values of that, we'll get a parabola. I'm wanting to know where does it cross this k-axis. So we'll need to factorize this expression and try and solve this equation. 12, 2 times 6, that's no good. 2 plus 6 is 8, 2, 6 minus 2's, well, it is. 2, so that would give us a 4. A 2 and a 6 looks a healthy choice. So the outside 2, 6k, the inside 2 are 2k, and how do we get a positive 4k from that? It would be plus the 6k minus the 2k. So we'd be adding 6k, subtracting 2k to get 4k, and negative 2 times positive 6 does give me negative 12. So there we've factorised it. This factor times this factor is 0. One of these two factors is 0. If k minus 2 was 0, k would be 2. If k plus 6 is 0, then k would be negative 6. So 2 and negative 6, the values of k squared plus 4k minus 12 look like this. And we're interested in when these values are greater than 0. In other words, when is this graph above the k-axis? Well, that happens when k is less than negative 6. We don't include negative 6 because strictly greater than 0, so we want the graph above the k-axis there. So k is strictly less than negative 6, or alternatively, if k is greater than 2, then the values of this quadratic expression, as shown by the heights in this graph, are above this k-axis. They're positive. So k is less than negative 6, or k is greater than 2. That's the range of values of k such that p lies outside the circle. That's Mr. Corsi signing out. Hope you enjoyed the video.